everybody. Today we're going to start 2.4, Tools for Studying the Brain. So we've discussed neurotransmitters and how our body sends messages throughout, but now we're going to focus on how exactly do we study the brain and know and understand how the brain functions. So we're going to take a look at both historical and contemporary research strategies and technologies that support brain research. Cognitive neuroscience is the study of brain activity and mental process. And a lot of this was influenced by the understanding of brain lesions. Brain lesions destroy part of the brain. But what this has led to was what we know as brain mapping, and the idea of understanding what parts of the brain are responsible for what actions, and really led to this development of cognitive neuroscience as a scientific study. One thing that we look at with cognitive neuroscience is your brain's ability to do what we call dual processing. And this idea, this definition is terrible. We know more than we know we know. That's not a very good definition, right? So what is dual processing? Well, dual processing just means that your brain can do two things at once. And we have what we call the high road. And this is what we think of when we think about the brain working. This is what we are conscious of. So the children in the background, I am conscious, I am aware of them talking, right? That would be the high road. But we have dual processing, so dual means two, right? So we have the high road we're aware of, but then we also have the low road. And this is what we are unaware of or in our unconscious. So things like your heart beating and breathing. These things happen automatically. So low road is unconscious, also can be automatic, things that we do without thinking. Historical brain study, before we had cognitive neuroscience, we had what was known as phrenology. And phrenology was started by a man by the name of Franz, whoops, it should be an N, Franz Gall. And what Franz Gall said, or what phrenology did, was it would study the bumps on your skull. So if you take a minute and just kind of feel around your head, you will notice there's a little bumps. Everybody's head's a little bit different. And what these bumps, it would also help if I spelled bumps right, huh, team? All right, let's do this. Sorry. All right. So he would study the bumps on your skull. And what they said is that these bumps could determine brain size. It could also determine your mental abilities and character traits. So if you were like hardworking or dedicated or loyal, could tell these things as well. This is an image here of what they would look for with phrenology. Obviously not very scientific, right? So that led us to the more scientific and more modern studies of brains. The first way to study a brain is to look at the actual structure of the brain itself, so the actual physicality of the brain. And there are two ways to do that, a CT scan or an MRI. A CT scan is going to use X-ray images that's going to produce cross-sectional, so meaning like slices across the brain, cross-sectional images. And we use this to study brain abnormalities We also would use it for injuries, tumors, and stroke. You can see if somebody had a stroke. The second way to look at the structure of the brain is to use what we call an MRI. And an MRI is going to use high resolution images. So they actually use a magnet to produce high resolution images of the brain. And this again can be used for abnormalities. So if I want to look at an abnormality for the structure of the brain, I'm going to use either an MRI or a CT scan. The great thing about this is it will give us, so the pros of either of these, CT or MRI, is it is going to show us pictures of the brain structure. But the con is that it's not going to tell us what the brain is doing. Does not tell us what the brain is doing. That's what we're going to discuss next. So to the left here, we have an EEG. And an EEG is going to record brainwave activity. It can tell us things like if a seizure is happening, it can also show learning disabilities. It can show even things like sleep disorders. The second image or the brain imaging technique that we have is known as a PET scan. And what a PET scan does is it shows us blood flow and oxygen to parts of the brain. So we know what parts are being activated. This can show brain activity. It also can show, in addition, drug activity on the brain. So that's what you see right here in this picture, right? You can see the difference of colors and brain activity from a normal brain to a brain on cocaine. Now, there is one type that cannot just show structures, but brain activity as well. And that is what we call an fMRI. An fMRI shows both brain activity and brain structure. It is going to be more precise and more rapid than other types of testing. And it can so fast that it can actually show you the location of a problem in less than a second. So it's very quick to do. Now, some people may ask, well, why don't you just do an fMRI instead of some of these others? Well, an fMRI is expensive and there's not as many fMRI machines as there are EEGs, PETs, or even a regular MRI or CT scan. For those of you that have ever needed a scan, you may have even found that you had to wait some time before you got one, and that's just because of the availability of the machines themselves. So today we discussed not just historical ways to look at the brain with phrenology, but also ways that we're going to look at brain structure
and brain activity, and that those are two different ways to look at the brain, but both are equally as important.